All right, so here we are in our last page of the geometry packet. We've got problems 31 through 35. These problems use some trig and some different things, but I am going to solve them using a simpler method where possible, so that I can just make sure it's kind of based on things we've already done. So in number 31, if QRST is a square and PQ is the square root of 2, what is the length of RU? So this is our piece that we're trying to discover right here. So the first thing we need to notice is that we're given that these two angles are both 45 degrees. That automatically means that we have an isosceles triangle. So I can label the legs are going to be equal in an isosceles triangle. And then it's a right triangle, so I can use the Pythagorean theorem. Remember, that's leg squared plus leg squared equals the hypotenuse squared. So I'm going to plug in my square root of 2, and square root of 2 squared equals c squared. So you can use your calculator, or the way I think about the square root of 2 squared is that it's like this. So that's the square root of 2 times the square root of 2, which is the square root of 4, which is just plain old 2. And square root of 2 squared again is 2, equals c squared. So 2 plus 2 is 4. So when we are looking for c, we want to do the square root of 4, which is just 2. So I figured out this hypotenuse here, and they tell us that QRST is a square, so I automatically know that all 4 sides of the square are the same. Now I've got this 30-degree angle given here, and this is what's called a special right triangle. So if this is a square, so we know that's a right angle, so we know this is a right angle. So if this is 90 and this is 30, add that up, that's 120, subtract from 180, we have what's called a 30, 60, 90 right triangle. And we call that a special right triangle because the rules of 30, 60, 90 right triangles say that we have the short leg, and then our long leg is always going to be the square root of 3 times whatever the short leg is, and then the hypotenuse is always double of whatever the short leg is. So those are the rules for 30, 60, 90 right triangles. And if you want to learn more about that, you can just Google that and watch a Khan Academy video, or there's a million teachers online that teach, and you can watch a video about 30, 60, 90 right triangles. It helps make ACT problems go faster if you know those rules. So anyway, this hypotenuse is what we're looking for, and that is choice D. In number 32, we're looking for BC right here. So what you've got is a right triangle over here and a right triangle over here. So pretty much, if you know the Pythagorean theorem, you can do a lot of stuff with right triangles. So that's what I'm going to do here. I'm going to do a squared plus b squared equals c squared. So I'm going to go square root of 13 squared plus square root of 23 squared equals c squared. So square root of 13 squared is 13, plus square root of 23 squared is 23. So altogether that's 36. So at least they were nice. They gave us a nice round answer for our c right here. So I'm just going to write over top of that. That's a 6. And now I've got another right triangle. And so I'm going to set up my Pythagorean theorem for my second right triangle here. The only thing is, this question mark is, this is a leg, it's not a hypotenuse. So we just have to be careful. I'm going to just come over here and keep writing. So I've got my leg that I don't know, squared, plus my other leg squared equals the hypotenuse squared. And you know, before we're going to study the Pythagorean theorem, we're going to do a whole unit on radicals. You can do this in the calculator. It's just, if you know the rules of radicals, you can do it in your head as well. So I've got question mark squared, and then 4 square root of 2 squared is like doing 4 times 4 and square root of 2 times square root of 2. So 4 times 4 is 16. Square root of 2 times square root of 2 is 2. So 16 times 2 is 32 equals 36. So if I subtract the 32, I get my missing side squared is 4, and square root both sides, and I get my missing side is 2. In number 33, this is something that we have studied. So let's just take a look at our diagram and see what kinds of things we see. The first thing I notice is that I've got a pair of vertical angles here. I'm going to put a dot on my 2 vertical angles. We have lots of vertical angles, but the one that's 60, that's the one I'm interested in. So I know vertical angles are equal to each other. So I can go ahead and label my 60. And then the other thing I've got is a straight line here. And this straight line is made up of 1, 2, 3 angles. All these angles wedged in together equal 180. So if I have x plus 2x plus 60 equals 180. So that's 3x plus 60 is 180. Subtract the 60 from both sides and we get 3x is 120. I get x equals 40. Now, they didn't ask me what x equals. They asked me what is 2x minus 60. So 2x would be 2 times 40, which is 80, minus 60. So I get 20 for that one. In number 34, I've got a triangle, and they give me the 3 side lengths, and they tell me it's similar. And so here is where, and then they say what's the smallest possible perimeter. So I'm gonna just sketch my 12, 14, 20. And then there's a bigger triangle over here. Okay, and we know that perimeters are similar just the way sides are similar. They want to know the smallest possible perimeter. So see, if I put this, one side is 40. If I put this 40 matching with the 12, then I'd have 40 and a bigger number and a bigger number. So if I want the smallest possible perimeter, I should match my 40 with the biggest side, because then I'll have smaller number and smaller number, and that's going to get me the smallest perimeter. Okay, so now I can see my scale factor is pretty easy to see. 20 times 2 is 40. So I don't even really need to set up a proportion. I can figure out that this is going to be 2 times 12, and this is going to be 2 times 14. So if I add up these 3 numbers, 24, 28, and 40, I've got 4, 5, 6, 7, 8, 9, and 92 is my smallest possible perimeter. And I'm just going to check my answer with that one. B, yes. Okay, B is correct. And the last one, number 35, we've got this funky shape here. It looks like it's made out of a bunch of rectangles. All distances are in centimeters. All the angles are right angles. What's the length of AC? So where is AC? Oh boy. Well, here's the deal. Where's my ruler? Not that I really need a ruler, but so I'm going to connect A and C. So the point being, we don't need to know all this stuff. We just need to see that here's a right triangle. We've got a 30 and a 40. And what is AC? So if you remember what I said about Pythagorean triples, the most common Pythagorean triple is a 3, 4, 5. So I can just look at this and tell you with a 3, 4, the C is going to be a 50. If you don't see that right away, you can go 30 squared is 900, 40 squared is 1600. So altogether it's 2500. And when you square root that, you get 50. So this is what the ACT is like. There's a lot of problems. They look complicated, but there's some little magical key that will unlock it for you. So that's it, I think. Yep, I'm back to the beginning. So we're all done with our ACT review, and please email me with questions or text me using the Remind app. And thanks so much for watching.